Have you ever gazed up at the night sky and pondered about the moon's origin? How did our natural satellite come into existence? This enigma has been a hot topic in the world of astronomy. Two main theories have taken center stage in this cosmic drama: the giant impact hypothesis and the co-formation theory. Each theory paints a unique picture of our moon's mysterious birth. Let's delve into the widely accepted giant impact hypothesis first, shall we? Imagine this. A Mars-sized body smashes into the early Earth around 4.5 billion years ago. Sounds catastrophic, right? Welcome to the giant impact hypothesis, the most widely accepted explanation for the moon's formation. In this scenario, the massive collision ejects a colossal amount of debris into space. Over time, this scattered debris, refusing to be lost in the cosmos, pulls together, coalescing to form our very own moon. But wait, there's another theory to consider: the co-formation theory. What if the moon and Earth were siblings born from the same cosmic dust and gas? This is the essence of the co-formation theory. It paints a picture of our moon and Earth forming side by side, from the very same swirling cloud of dust and gas that marked the infancy of our solar system. Like cosmic twins, they grew together, each shaping the other's destiny. A fascinating concept, isn't it? Two intriguing theories, but which one holds the truth? Regardless of how it formed, the moon's birth significantly influenced Earth's early history. Imagine a young Earth spinning rapidly on its axis. This rotation was slowed by the moon's gravitational pull, giving us our 24-hour day. The moon also stabilizes Earth's tilt, making our seasons possible. Tides driven by the moon stirred the primordial soup, possibly sparking the genesis of life itself. Next time you gaze at the moon, remember the cosmic drama that might have led to its existence.